Hello, my name is Frank Calderone. I'm the Network Security Practice Lead at Solutions for Networks, and today I'm going to discuss the best practices for network security.
Let's start off with a definition of what network security is. Network security is a specialized field in computer networking that involves securing a computer network infrastructure. Network security is typically handled by a network or system administrator who implements the security policy, network software, and hardware needed to protect a network and the resources accessed through the network from unauthorized access, and ensure that employees have adequate access to the network and resources to work. A network security system typically relies on layers of protection and consists of multiple components, including network monitoring and security software, in addition to hardware and appliances. All components work together to increase the overall security of the computer network. Network security is made up of all your security components, i.e. firewalls, IDS, IPS, antivirus, anti-malware, etc. Defense in depth is a key pillar to implementing a good network security system. Defense in depth, a term borrowed from the military, is an approach to layering your security to avoid risk, so that if one layer proves to be inadequate or is breached, another layer will be there to provide protection. Defense in depth is architecting network security components in such a way as to provide the utmost protection to your organization. Now let's look at some scenarios where a good network security framework has been implemented. Here we have an overly simplified view of a corporation's network. It consists of a firewall at the perimeter of the corporate network. The firewall is responsible for allowing only valid traffic inbound to internal resources and at the same time restricts outbound traffic to only valid destinations. Today's firewalls, sometimes referred to as next-generation firewalls, perform multiple functions such as application layer firewalling, user identification, URL filtering, SSL decryption, antivirus, anti-malware, and other threat detection capabilities. A next-generation firewall does a lot of defense in-depth strategies all on one platform. IDS/IPS, or intrusion detection and prevention systems, by themselves can detect and/or stop malicious software using signatures. Today's IDS/IPS systems rely heavily on machine learning and AI. Email gateways are responsible for the inbound and outbound email from an organization. They can detect and prevent spam and malicious links sent in emails, in addition to scanning inbound and/or outbound emails for viruses and malware. Some of the advanced email gateways even provide data loss protection. Network security monitoring servers come in all flavors, from simple syslog servers to full-blown SIEMs, i.e. security, incident, and event management. It is critical in today's environments that security incidents and events are not only logged for historical use, but in some industries, logging events must be maintained based on state and federal regulations. Authentication servers also come in a wide variety. One example is an Active Directory server utilizing Radius or Kerberos for authentication. Multi-factor and two-factor authentication used to be something only financial institutions were implementing because of the cost and complexity. But in recent years, vendors have made it simple to implement, and the cost is within reach of most organizations. Your security should also extend to the corporate user's desktop in the form of endpoint protection. Effective endpoint protection software will provide firewalling, antivirus, internet security, encryption, intrusion detection, and application controls. It should also report to a centralized management server. In the first scenario, we have a remote user attempting to access the corporate network. The normal method for remote access is using a VPN, virtual private network. The user starts the VPN client and is prompted to enter their credentials. The user enters their username password, and the firewall, which has a link to the authentication server, sends the request over for validation. The authentication server does a lookup, the user is validated, and the OK response is sent to the firewall. The firewall then sends the response to the user, granting them access. Additionally, In some instances, the firewall may go one step further and check the user's workstation to ensure they have the current OS patches installed, antiviruses enabled, etc. before allowing them access to the corporate network. Now let's look at how proper network security can stop a ransomware attack. A phishing email with a malicious attachment is sent by a hacker to corporate user Bob. There are some cases with next-generation firewalls that malicious inbound emails may be stopped, i.e. via country blocks, domain blocks, or attachment filters. But let's say the firewall and IPS systems allow this email through. Not uncommon since a lot of organizations allow inbound email through their perimeter firewalls unfiltered. The email gateway now has the malicious email, and according to the policies and content filters applied, there's a good possibility that it will be quarantined and the threat stopped. But what if it isn't? The email will be delivered to Bob's inbox. Unsuspecting Bob clicks on the email and reads it. Just recently, Bob has had end-user training from the company's security department that taught him how to be more aware of phishing emails and how to spot them. Bob suspects this is a phishing email and deletes it. But what if Bob does not suspect the email and clicks on the attachment? A series of events now happen. A malicious worm is downloaded to Bob's computer and begins to run. If Bob has some of the new endpoint protection software installed in his computer, then in a lot of cases, it will stop this process and thus kill the attack. If not, then the malicious file will attempt to connect to its CNC server, i.e. command and control, on the internet. Once again, this threat may be mitigated by the next generation firewall. For instance, the firewall can be configured to block outbound attempts to malicious DNS. DNS plays a big part in a ransomware attack. If the malicious file, also called a dropper file, is unable to connect to its CNC server, this effectively kills the ransomware attack. Unfortunately, the dropper file is still on Bob's PC, and that will need to be deleted. But this gives the IT security team enough time to respond to any alerts that may have been triggered by the firewall and inspect the logs on their network monitoring devices. Unfortunately, in a lot of cases, this outbound request will be allowed because a lot of companies do not restrict outbound connections from internal resources. The CNC server now has communications with the dropper file on Bob's PC and sends the information to encrypt the drive. As you can see, implementing a sound network security architecture is essential to any organization's IT security strategy. I hope you have found this video informative, and I thank you for watching.